Next up is Jakub from Cloudflare.
Hello everyone, my name is Jakub and I will show you how to steer connections to sockets with BPF socket lookup hook. So who am I? I work at Cloudflare while I help build reverse proxies and maintain the internal kernel. I also contribute to the network stack and BPF subsystem in Linux. So our goal for today is to deploy an echo service that will respond on 3 different ports but use just one TCP listening socket. We'll need a VM with at least 5.9 kernel, a BPF tool for that kernel version, as well as libbpf and kernel headers. This is going to be a speed run, so instructions and code for everything I show will be also on GitHub. First, we need an echo server. Netcat that spawns the cat tool will do. We bind our server to quad 7 port on loopback. And next, we check our VM's external IP and confirm that the echo service is not running on the ports we want yet. So now we're going to program the socket lookup. What is socket lookup? Well, it is a stage of the receive path in the network stack where the L4 protocol searches for a socket to accept an incoming packet. We'll attach a BPF program to the socket lookup. That program will examine an incoming packet metadata and check if the packet is destined to one of the echo service ports. If so, it will dispatch it to the echo server socket. So let's take a look at our BPF program. First, we need to define the 2 maps, one to keep a list of open ports and another to store the listening socket. Then the body of our program, in which we check if the echo service is configured on the packet's destination port. If so, we grab the echo server listening socket and dispatch the packet to that socket. Now that the program is ready, we have to build it. And once built, we can load it into the kernel and pin it onto BPF file system for easier access. Notice that the BPF tool has already created the maps that the program is using. We need to make these maps accessible to the unprivileged user who owns the echo service process, in this case, Vagrant. That's why it will pin these maps on a dedicated BPF file system where the user will be able to open them. So now it's time to put the echo service listening socket into the BPF map. First, recall that our server is running and the SS tool will show the PID and the file descriptor number of the socket. To put the socket in the map, we need to get a duplicate file descriptor for that socket. And there are a few ways to do it, but if we know the process and the file descriptor number, pidfd getfd system call will be the easiest one to use. So let's run a helper program that does just that. It gets a duplicate file descriptor for the socket using pidfd getfd, and inserts it into the echo socket BPF map. Now, if we dump the map context, we see that the socket has been stored. What's left is to put our BPF program in action by attaching it. Sockets live inside the network namespace, and so we attach the echo dispatch program to a network namespace by creating a BPF link to it. Next, we also need to configure the dispatch program. For that, we populate the echo ports map that drives the dispatch program by inserting the 3 port numbers where we want the service to be available into the map. Well, all should be set well. If we rescan the ports on the VM, the port numbers we have just enabled appear as open. And we can also test the echo service on each of the ports we have opened up. It works. So if you want to use BPF socket lookup, there is documentation, tests that can serve as examples, as well as blogs and presentations from earlier work. Also, please watch out for a follow-up blog post on the Cloudflare blog, where we'll also talk about UDP services. Thank you for listening, and I'm happy to take any questions.
Awesome presentation, Jakub. Always great to hear from you guys on the Cloudflare blog, and you're participating in a lot of eBPF communities, so definitely watch out for that blog post coming up.